Hello everyone, welcome back to Z Physics. What I would like you to do, guys, to begin with today is have a go at the following three questions. So we have questions A, B, and C. In each of those cases, we have some currents which are either entering or exiting a junction. And what I would like you to do is have a go at calculating those unknown currents in each of those cases. And this will be a perfect opportunity for you guys to pause this video and attempt the question. Okay, now let's have a look at those answers. In the first case, this answer here is 3 amps. So we can see that if 10 amps are going to a junction and 7 amps are coming out, then we're only going to have 3 amps leaving the junction as well. In the next case, which is case B, notice that we have changed the direction. In this case, we have 10 amps going into the junction and 7 amps going into the junction. So that means that we must have 17 amps leaving the junction, like so. And the final question, which is a little bit trickier, I'm going to go through it in a minute, but let me just give you the answer first of all, see if you guys have gotten this right. The final answer is 18 amps. Now, what was the rule which I used to essentially determine those numbers? Let's have a look at Kirchoff's first law. So Kirchoff's first law says that the sum of the currents entering a junction is equal to the sum of the currents exiting a junction. And this law is a statement of a very fundamental principle, which is the conservation of charge. Let's look at this into a little bit more detail, and let's do the final example which I asked you guys to do at the beginning of this online lesson. So sum of the currents entering a junction, I'm going to use this summation sign. I'm going to call the sum of the currents entering the junction I subscript in. That's got to equal I subscript out, which is the essentially the currents exiting the junction. When we look into this diagram in a little bit more detail, we can see that the 15 amp current and the 6 amp current are entering the junction. So 15 plus 6 amps, and that's got to equal the amount of current exiting the junction. Current is never just lost. I mean, electric charge is never just, lost anywhere. It's still somewhere. It doesn't just vanish. And we can see that this unknown current, should call that just X, and just for consistency I'm going to leave a little X over here, and additionally the 3 amp current is also leaving the junction as indicated by this arrow, like so. Okay, well, all we need to do is just really rearrange for X. So 15 plus 6, that is equal to 21, is equal to X plus 3, which means that X will be 21 minus 3, like so, which is going to give us 18 amps. Okay, folks, so once again, Kirchoff's first law states that the sum of the currents entering a junction is equal to the sum of the currents exiting a junction, and this law is a statement of the conservation of charge. If there are any further questions, please feel free to drop a comment down below, and please consider subscribing. Thank you.